Hello, my name is Paidamoyo Kachambwa. I am the Bioinfromatics team leader at the Center for Proteomic and Genomic Research, CPGR. Bioinformatics, in short, is an interdisciplinary field that combines biology, computer science, mathematics, and statistics in order to analyze and interpret biological data. I hold a BSc in computer science and microbiology. I was then interested in combining the two majors in order to use computational methods to better understand biological data, and therefore pursued a BMed Sci Honors in Bioinformatics and later an MSc Med in Bioinformatics. Currently part-time, I am in my second year of pursuing a PhD in health sciences education. I was interested in this after experiencing how the medical sciences field was and is constantly growing and evolving. The CPGR is based in Cape Town, South Africa, and is a non-profit organization with a for-profit subsidiary called the Artisan Biomed. The organization provides state-of-art omics services to the life sciences and biotech communities in South Africa and across Africa on local and regional and international projects to create a fit-for-purpose offering for customers from across academia to industry. Bioinformatics is a critical skill and is a broad field with different specialities. Due to the scarcity of the skill, many organizations adapt for use, especially in an organization like the CPGR, which has a wide range of different projects and therefore has a constant change in the scope of work that we do. The team has 4 members, each with a different strength that is leveraged depending on the aspect of the project. At the same time, we learn from each other in areas that we can improve on. I would like to think of us as the Power Rangers, where the individual Power Rangers, the Zords, combine into a Megazord in order to tackle more complex problems. Of all of the solutions that come out of the organization, I am particularly interested in projects that unravel the African genome, a term usually used in Artisan Biomed. There is a drive at the CPGR to consider the growing need for applications in disease with respect to better understanding how certain diseases affect people of African descent. Research shows gaps in data from people of African descent, meaning there is a gap in characterizing and therefore understanding the African genome versus how well characterized and understood, for example, European ancestry is. The African genome is also the most diverse, making it complicated to understand, but its diversity is thought of as the key to better understanding some diseases and creating solutions. Studies clearly show that some diseases can have a varying effect on an individual based on their ancestry. For example, prostate cancer is twice as aggressive and not well characterized in men of African descent versus those of European ancestry. And we're currently involved in the MadCap project, which actually focuses on this. Interestingly, the bioinformatics team comprises of a South African, a Nigerian, a Kenyan, and myself, a Zimbabwean, which reflects the Pan-African reach and approach that is taken here. Knowing more about the African genome can be achieved as a starting point by producing and analyzing data that comes from people of African descent. I will take you through a summary of one of the many interesting projects that I've been a part of during my time here at the CPGR, human leukocyte antigen, HLA typing. Although the typing is done as part of donor matching procedure in transplantations, which may include entry of the donor into the registry, the drive to build an African registry by the Sunflower Fund has far-reaching positive implications. The data gathered can and is being used by researchers to get better insights on HLAs and their association with health. In particular, WAIT has lagged to provide health insights for people of African descent. The diversity of the African genome may also increase chances for global patients in finding a match. As the world becomes a global village, genomes are becoming more diverse, and also genetic diseases are generally due to variations in SNP. The diverse African genome may be the key to better understanding these variations. Generating data is only the first step, but nonetheless an exciting step. And once more data is available, there are a lot of downstream bioinformatics projects that are just rearing to take place.